Okay, guys, hopefully you watched video number 1. You probably went, whoa, that's something weird or totally different. Hang in there. Please also watch this video number 2, number 3. There's going to at least be 4 or 5 in this set. Okay, and they're just going to build one upon the other. Okay, so one thing we've been learning in class is a good old 45-45-90, right? What do we know about a 45-45-90? Well, we know that if that's 45, of course that's 45, right? That's where it gets its name, 45-45-90. What else do we know? We know whatever this side is, this side's going to be the same. So if this is 1, that's 1. And then we could use Pythagorean theorem, but we know that this here is going to be square root of 2 times 1, or that 1. And there's your 45-45-90. On the SAT test, guys, you'll see it something like this. They'll at least tell you 145, and they'll go x times the square root of 2. So in our cases, x's are 1s. Okay? That's all I did over here. Okay? So far, so good, right? Well, what's the problem, of course, is we want to relate this actually to the unit circle. Imagine instead of 2 here, how could I make it a 1? Couldn't I divide by a square root of 2? Do you agree? Square root of 2 divided by square root of 2 is 1. So I'm just going to divide every side by square root of 2. Now, hopefully we realize that there's a thing called rationalization we got to do, right? So I'm going to rationalize 1 divided by square root of 2, and I'm going to get square root of 2 over a regular 2. So, in a nutshell, we have a 45-45-90, right? And what we learned, if the radius is 1, we know that this side was square root of 2 over 2, and this side's going to be the same, square root of 2 over 2, right? Notice, to prove that this is right, if I take one of the sides and I times by another square root of 2, wouldn't I get 2 over 2, which of course is 1, which is what that's supposed to be right there, right? Okay, so stay with me, guys. We're almost done with this video. What I wanted to show you is that if you now look at our 45-45-90 triangle right here, okay, well, remember, this point right up here, follow the red, wouldn't this right here, in other words, be our x coordinate, right? And wouldn't this right here, vertically, be our y coordinate? So that point right there, would it not be square root of 2 over 2, square root 2 over 2? In other words, our x and our y's are the same, right? And that's how we can get this perfect 45-degree angle there. Okay? And this is basically what I want to lead you to. We know the coordinates of that point at the tip of that 45-45-90-degree triangle is square root of 2 over square root 2 over 2, square root 2 over 2. Okay? Now, remember also, guys, in the previous video, that we learned that x is also the cosine of theta, and our theta is 45. So what we just learned, you see, is a cosine of 45 degrees is square root of 2 over 2. Right here, we just learned, remember, y is sine of theta, and if theta is 45 degrees, because again, that's what we have right there, we know that the y coordinate, again, was the same, square root of 2 over 2. Okay? And we're going to leave the video right there, guys. Pause the video right now. Take notes on this. Think about it. I know it's still a little weird, but once it all comes together, it should make a lot of sense. Again, maybe you want to pause the video there, or simply rewind and watch the video over again. But that concludes video number 2. See you in class.